In this video, I will cover factoring the difference of two squares, factoring by grouping, and then factoring trinomials, where a equals 1 and then where a does not equal 1. So let's do some examples of factoring the difference of two squares. The way that you factor x squared minus 16, which are both perfect squares, is by taking the square root of each term. The square root of x squared is x. The square root of 16 is 4. So we're going to have a plus and a minus in these parentheses because then the middle terms will cancel out. So the wonderful thing about factoring is that you can always multiply it back out to check your work. So we're going to do that to show that this is indeed factored correctly and to help make sense of why we factor it this way. So x times x is x squared. X times negative 4 is minus 4x. 4 times x is plus 4x, and then 4 times negative 4 is negative 16. So you can see that these two terms will cancel out because one's a negative and one's a positive. Now this is always going to happen when you factor this way and you have the exact same terms in both parentheses with a plus and a minus, then those middle terms will always cancel out. So this is equal to x squared minus 16. So let's look at another example. If you have a difference, meaning that there's a minus sign here, a difference of two perfect squares. 4x squared is the square of 2x, and 25 is the square of 5. Then you can immediately put the square roots in the parentheses, 2x plus 5 and 2x minus 5. Now the order of these does not matter. You can put the minus first and then the plus. You can multiply it back out to check it. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is positive 10x, so those will cancel out. Positive 5 times negative 5 is negative 25. So one thing that you do have to be careful of is that if you see a plus sign instead, something like this, this is not factorable. So yes, the square root of x squared is x, and this is also a perfect square, but you can see that if you try to factor this as x plus 3 times x plus 3, that you would get 6x in the middle, which you do not have here, because you would have x times x is x squared, x times 3, 3 times x again, and then 3 times 3. So having a plus and plus would not give you this because you're missing the 6x here. Likewise, you could also not make it equal x plus 3 times x minus 3 because you are supposed to get a plus 9, and here you would get a negative 9. Also, you could not do two minus signs because then you should have a negative 6x in the middle here. So if you get something like this, this is not factorable. And your directions will usually say that. Factor if possible, or say it's not factorable if it's not. So this method only works for the difference of two squares if you have the minus sign. Let's do one more of these. If you have something like this, 18x squared minus 98, you have two terms and it has a minus sign and it has an x squared. So it looks like the difference of two squares, but of course 18 and 98 are not perfect squares. So the first thing that you always want to do when you're factoring is factor out any greatest common factor. And so both of these are divisible by 2. And if we factor out a 2, 18x squared divided by 2 is 9x squared, and 98 divided by 2 is 49. So we do need to make sure we leave this 2 out front because we are factoring here. So if we multiply the 2 back through, we would get the 18x squared and then the minus 98. Now in parentheses, we do have the difference of 2 perfect squares. This is a square of 3x, and this is a square of 49. And so when you're factoring, you have to make sure that you factor completely. So factor everything that you can. And so you can put 3x minus 7 and 3x plus 7. Again, the order does not matter, and this is fully factored. So if you see something that kind of looks like it could be the difference of 2 squares, look for that greatest common factor first, factor that out, and then you might be left with the difference of 2 squares. Now let's do 2 examples of factoring by grouping. Now I will also use factoring by grouping in the end of the video when I'm factoring trinomials where a does not equal 1. So factoring by grouping is something that you want to do when you see 4 terms. So we're going to group these 2 together, and we're going to group these 2 together, and we're going to get a common factor when we do that. So what is the greatest common factor between this term and this term? 2x. So we're going to factor out 2x. 10x squared divided by 2x is 5x, minus 6xy divided by 2x is 3y. And then we're going to look at these 2 terms that we're grouping together. And what is the greatest common factor between this term and this term? 11. So we're going to factor out 11. 55x divided by 11 is 5x, minus 33y divided by 11 is 3y. Now when you're factoring by grouping, whatever is in parentheses here has to match what's in parentheses here. This will always happen when you're factoring by grouping. When you're factoring by grouping, you're going to factor out that common factor that's in the parentheses here and here. And then in the other parentheses, you're going to be left with what's on the outside here, 2x plus 11. And that is your final factored form. So if you multiplied this back out, you would end up with this original expression. 5x times 2x is 10x squared. 5x times 11 is plus 55x. Order does not matter. The minus 3y times 2x would give you your negative 6xy. Your minus 3y times 11 would give you your minus 33y. So this is the way that it's always done. You factor out this common factor. This factor is times 2x, and this factor is times plus 11. Let's do another example. Again, since we see 4 terms, we know that we should try factoring by grouping. So it really depends on what expression you have to begin with in order to decide which method you're going to use. So we're going to group these 2 together, and then we're going to group these 2 together. And the greatest common factor between 20x squared y and 8xy is what? 4xy. And then when you divide 20x squared y by 4xy, you get 5x. 8xy divided by 4xy is 2. Now you know that you have factored out the greatest common factor between these 2 when these 2 terms have absolutely no common factors. The greatest common factor between these 2 is only a negative 1. So we're going to just factor out a negative 1. Now make sure you put this 1 here because that's just going to help you when you're factoring in the next step. And so you're left with 5x plus 2. because you're factoring out a -1 out of this term and this term. So this is a +2. Since you have the parentheses here, you can see if you multiplied it back out, you would get -5x minus 2. So very important to factor out that negative out of this term. And now you see that what you have to have when you're factoring by grouping is you have the exact same thing in both parentheses. And that way you can factor it out, 5x plus 2. And then in the other parentheses, it's what's left. It's 4xy minus 1. And of course, if you're working on a quiz or a test, you would really, if you have extra time, you would really want to multiply everything back out to ensure that you have what you had in the original expression. Now we'll do some examples of factoring trinomials where a equals 1 and ax squared plus bx plus c. So we do want to make sure that we have this order, the standard form, the x squared term, and then your x term, and then your constant c. And so you can see that a equals 1 here. There's a 1 in front of our x squared. That's not written, but we know that it's there. And so we're going to do several examples of these, and then we're going to do examples where this a does not equal 1. Now, when a equals 1, all we're looking for are two numbers that multiply to c and add to b. In this case, that would be finding two numbers that multiply to 2, since c is 2, and add to 3, since b is 3. So those two numbers are positive 2 and positive 1. And those are the two numbers that will go in our factors. The order does not matter. So this is equal to x plus 2 times x plus 1. Let's multiply it back out to check it, and you can see where this reasoning comes from, that these two numbers are the ones that multiply to 2 and add to 3. So when we FOIL this, we get x times x is x squared, plus 1 times x is 1x, plus 2 times x is 2x, plus 2 times 1 is 2. And now you can see why these are the two numbers that will add together to get b and multiply together to get c. When we combine these like terms, we do end up with our original trinomial. So this is to check our work, and this is in factored form. Here's our next example, x squared plus 2x minus 15. So we need to find two numbers that multiply to negative 15 and add to positive 2. Those two numbers are positive 5 and negative 3. So those are the numbers that go in our factors. And the order does not matter. We can do x plus 5 times x minus 3. And that is fully factored. Again, we can multiply it out. X squared minus 3x plus 5x. So that will give you your plus 2x here in the middle. This is positive, so your higher number is positive. And then negative 15 you get from multiplying positive 5 times negative 3. Here's our next example, x squared minus 12x plus 32. So we're finding two numbers that multiply to a positive 32 but add to a negative 12. So both of those numbers will need to be negative then, because a negative times a negative is a positive, and a negative plus a negative will be this negative. So the two numbers are negative 8 and negative 4. So our factors are x minus 8 times x minus 4. If we add negative 8 and negative 4, we'll get negative 12. Multiply negative 8 times negative 4, we'll get positive 32. Our next example is x squared minus 5x minus 14. So we need two numbers that multiply to a negative 14 and add to a negative 5. So one of those numbers will need to be negative and one will be positive. Since we want -5, the two numbers will be -7 and +2. So our factors are x minus 7 times x plus 2. Since -7 plus 2 is -5, and -7 times 2 is -14. Here's an example that at first glance does not have a as 1. But the thing that we always look for first whenever we're factoring is a greatest common factor. All three of these terms are divisible by 3. So we're going to factor out 3 first. So 3x squared divided by 3 is x squared, plus 18x divided by 3 is 6x, and 81 divided by 3 is 27. And now in parentheses, we do have a trinomial that has a as 1. This 3 needs to just stay on the outside here because we always want to make sure that when we factor is equal to the original expression. If we multiply this 3 through, we would see that we would get this. But now we can factor this like we did the other examples. We're looking for two numbers that multiply to -27 and add to 6. So what are those two numbers? +9 and -3. So those are the numbers that will go in our factors, x plus 9 times x minus 3. And that is our fully factored form with that original 3 on the outside. Now let's do trinomials where a does not equal 1. Our first example is 5x squared plus 8x plus 3. So we look for greatest common factor first. Now there are no common factors with 5, 8, and 3. So here we really do have a trinomial, 3 terms, where a, this number in front of x squared, does not equal 1. Now there's several methods to factor these, and I'm going to cover 2 of those. The first one is to guess and check. We know that this is going to be 2 factors, and we can see that 5 really doesn't have many factors at all. It's a prime number. It's just 5 and 1. So we're going to have 5x here and x here. And since this is plus and plus, we know that we're going to have plus here and plus here. And 3 also does not have many factors, just 3 and 1. And so your only options here are either the 3 will be here and the 1 will be here, or the 1 will be here and the 3 will be here. And so this is what I mean by guess and check. We really need to see which one of these factored forms is equal to this trinomial. So we're always thinking about foiling whenever we factor. And so here, let's check this one. We would have 5x squared, and we would have 5x plus 3x, and that would give us our 8x in the middle, and then we have 3 times 1 is 3. This one does not work because we would get the 5x squared, but we would get 15x plus 1x, which would be 16x. So this one does not work, and of course, you know, once we checked this one and it worked, we knew that this was the answer. So this method is pretty easy to do when A and C don't have many factors, and you can just put your numbers in the parentheses and then multiply it to check it. But let's look at one where A and C do have a lot of factors. So in this case, 6 has some factors, and 20 has a lot of factors. And so you could do guess and check and maybe see if you get lucky. So, you know, one of the options would be a 6x and an x to make 6x squared. And to make 20 might be like 4 and 5. And you do have a plus and a plus since these are both positive. But it could also be the other way around, 6x plus 5 and then x plus 4, or maybe it's 3x and 2x to make 6x squared. Maybe it's 10 and 2 to make 20. So you can see that you're just going to have a lot of options, and it's just going to make the guessing and checking a little bit more challenging. So there's this method called the AC method. So I'm going to teach that to you now. The first step to the AC method is to find two numbers that multiply to AC and add to B. So our quadratic is in standard form, and so A is equal to 6, B is equal to 23, and C is equal to 20. So A is always the coefficient of x squared, B is your coefficient of x, and C is your constant. And so in this case, we need two numbers that multiply to A times C. So 6 times 20, 120, and add to B, which is 23. There are several ways to find these two numbers. You can use a calculator, or you can even do the prime factorization. You can just do guess and check. The two numbers are 15 and 8. Now this is a little bit different from how we were factoring before. When we found the two numbers, they went in our parentheses. These two numbers will not go in our parentheses. This is a different method. So what we're going to do instead is we're going to put x's on these numbers, and we are going to substitute them in for this term right here, and then we're going to have 4 terms, and then we'll use our factoring by grouping. You can see that this expression is still equal to the original expression. 15x plus 8x is equal to 23x. Now that we have 4 terms, we can factor by grouping. So we'll group these two together, and then we'll group these two together. The greatest common factor of 6x squared and 15x is 3x. So we'll factor that out, just like we did earlier when we were factoring by grouping. And so what's left is 2x plus 5. And then we group together these two. The greatest common factor is 4. So we factor out of 4. We're left with 2x plus 5. Now, when we do this method, these two factors will always be the same, just like they always should be when we're factoring by grouping. So our first factor is 2x plus 5, and our next factor is what's left, the 3x plus 4. If we multiplied this back out, we would see that it's equal to the original. 2x times 3x is 6x squared. 2x times 4 is 8x, plus 5 times 3x is 15x. Those add together for 23x, and then 5 times 4 is 20. So this method might seem a little bit difficult at first, but once you do several examples of this, it gets a lot easier. Our next example is 12x squared plus x minus 35. So we're going to, since a is not 1 and we don't have any common factors to factor out, we're going to use the AC method and find two numbers that multiply to AC and add to B. So in this case, A is 12, C is negative 35, so we can always write that down. A is 12, B is 1, because there's a 1 in front of that x, and C is negative 35. Make sure you leave that negative on there. And so now we have to find two numbers that multiply to 12 times negative 35 and add to 1. When we multiply 12 and negative 35, we get negative 420, and B is 1. So what are the two numbers that would multiply to negative 420 and add to 1. 21 and negative 20. We will put x's on both of these numbers, and we will make that substitution for that middle term, and so that we can factor by grouping. So we'll have 12x squared plus 21x minus 20x minus 35. Now the order of these two actually really doesn't matter. Like if you would have said negative 20 and 21, and you would put negative 20 here and 21 here, it doesn't matter. You're still going to get the exact same answer at the end. So now we're going to factor by grouping. And so we have these two terms together and these two terms. The greatest common factor between 12x squared and 21x is 3x. We're left with 4x plus 7. And then we need our minus sign here. The greatest common factor between 20x and negative 35 is negative 5. And we're left with 4x plus 7. Again, you can always multiply back out to check it, because a negative 5 times 4x would give you negative 20x, and negative 5 times positive 7 would give you a negative 35. Again, you have the exact same thing in both parentheses, which you must have. You're going to factor out the 4x plus 7, and you'll be left with your 3x minus 5. And that is your final answer. So if you multiplied it back out, you could be sure that you get this original trinomial. 4x times 3x is 12x squared. 4x times negative 5 is at negative 20x. 7 times 3x is 21x. So when you add those together, you would get positive x. And then positive 7 times negative 5 would give you your negative 35. Let's do one more example. When we're factoring, we always look for greatest common factor first it will always simplify your factoring process. And so do 28, 22, and 30 have any common factors? Yes, a factor of 2. So let's factor out a 2 first, and then we'll be left with a simpler trinomial to factor inside the parentheses. So this 2, we're just going to carry this down and just leave it out front, but we kind of ignore it for the purposes of factoring out this one. Now we need to use our AC method, which is finding two numbers that multiply to AC and add to B. And we know that A is 14, B is 11, and C is negative 15. In that case, that would be finding two numbers that multiply to 14 times negative 15, which is negative 210, and add to 11. So what are those two numbers? Again, a calculator can really help here to find those two numbers. The two numbers are 21 and negative 10. We'll add x's to both of these numbers, and we'll make that substitution for our bx. So let's just keep that 2 out front so we don't forget about it. But we're focused on what is inside the parentheses. And now we'll do our factoring by grouping. We'll group these, we'll group these. So the greatest common factor for 14x squared and 21x is 7x. So we're left with 2x plus 3 minus the greatest common factor here is 5. So we'll have a negative 5, and we'll have 2x plus 3. We have the same thing in this parentheses and this parentheses, which means that we can factor it out. So our first factor is 2x plus 3, and our second factor is the one we have left, 7x minus 5. So this is fully factored. If we wanted to check it, we could multiply everything that's in these parentheses and then multiply everything by 2 to make sure that we get this original trinomial. I hope you've enjoyed this video. Please like, subscribe, and comment, and check out my other videos.